Oh, hi there. My name's Peter Grindrod. I'm a professor in the Maths Institute of the University of Oxford. I research into the mathematics of consciousness. Now, the mathematics of consciousness is unusual in a way because we have to understand why we have conscious experiences inside our minds at the same time as we're doing all this cognition, processing information that's coming in and providing response signals going out. I published in IgMin because I wanted to have a fairly broad readership, not just a mathematical readership, although mathematicians certainly read and enjoy that publication. But I was interested particularly in the multidisciplinary nature of the contributions that are made in areas like consciousness. Mathematical consciousness itself broadly has three approaches. There's quantum consciousness, which is the idea that somehow evolution has managed to capture quantum advantages that have given an evolutionary advantage to human beings as organisms, and that somehow conscious experiences have something to do with conscious approaches. There's no great evidence for that, or even for more generalized quantum biology, that anything in biology which is relatively warm and wet compared to the types of physical conditions and timescales one would want to have for any quantum effects. So quantum technologies, while doing very well in some areas of technology and ICT, the jury's still out whether they can be part of something in biology, and especially whether they can be part of something in consciousness. It's a rather difficult idea to disprove, though, so it's hanging around, and it provides a number of thought experiments and useful work for people qualified in quantum physics and quantum applications of mathematics. Another approach is also top-down. It's integrated information theory, and that gives the idea that there's a sort of measure of some property within complex systems, which is related to their consciousness. It's called phi, so if you have a big phi, you're very conscious, and if you have a small phi or zero phi, then you're just a sort of lump of inert stone or something, and hardly conscious at all, and then everything in between. And it kind of asserts that consciousness is a property of the whole, and it works top down because you want it to be measuring some kind of experience that the system is having, while at the same time the system was actually developed to do cognitive processing and that kind of thing. A third approach is to go and get a very large model of the complex system. We know what brains are made of. They're made of lots of cells, and they're all talking to each other at that level. If we don't go down into the internal nature of each cell, just imagine we've got a network of 10 billion cells, and they're all talking to each other. And so we can now simulate those on massive computers, and we can reverse engineer them and get some idea as to what's actually going on inside. And that leads to predictions. These are testable predictions, so in the sense of Popper, we could agree with or refute theories based on hypothesis born of those simulations. So those three approaches are what I wanted to contrast, and I wrote a paper called Wishful Thinking about Consciousness, and published it in IgMin. It was a very easy process. It's given it a lot of exposure to different types of readers, and it only really took 4 months to submit a manuscript and get it through and out into open publication. So it's an experience I'd certainly repeat next time I want to reach a sort of more general biology, medical, engineering, and indeed theoretical science types of audience. It was a good experience, and it was helpful to me in my career. Thank you very much.